We now discuss the solution of a problem from the section three-dimensional geometry. This question is on the concept of shortest distance. This question has appeared in the joint entrance examination main held on 25th June 2022 in the second shift. The given question is, let L1 be the line in xy plane with x and y intercepts 1 by 8 and 1 by 4 root 2 respectively, and L2 be the line in zx plane with x and z intercepts minus 1 by 8 and minus 1 by 6 root 3 respectively. If D is the shortest distance between the lines L1 and L2, then D power minus 2 is equal to. We have two lines L1 and L2. L1 is a line in the xy plane with x and y intercepts respectively 1 by 8 and 1 by 4 root 2. And L2 is a line in zx plane with x and z intercepts minus 1 by 8 and minus 1 by 6 root 3 respectively. If D denotes the shortest distance between L1 and L2 required to get the answer for D power minus 2. That is our given question. We now discuss the solution of the problem in detail. We have L1. It is a line in xy plane with x and y intercepts 1 by 8 and 1 by 4 root 2 respectively. Now we can write down the equation of the line L1 as x by x intercept is equal to y by y intercept is equal to 1 with z is equal to 0. That is given by x by x intercept 1 by 8 plus y by y intercept 1 by 4 root 2 is equal to 1, z is equal to 0 because it is in the xy plane. So clearing the LCMs, you will get 8x, no clearing, 1 by 8 becomes 8x, yes, 8x plus 4 root 2y is equal to 1 with z is equal to 0. Okay. Now we take two convenient points on this line. How do we get it? So put y is equal to 0, and x is equal to 1 by 8. Then x is 1 by 8, y is 0, z is equal to 0 satisfies this equation. So 1 by 8 comma 0 comma 0, and similarly x is 0 and y is 1 by 4 root 2 and z is 0, that is this point will also lie on this one. So this line is passing through these 2 points. And we recall the equation of the line passing through two given points, A with coordinates x1, y1, z1, B with coordinates x2, y2, z2. It is given by x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. So in our context, x1, y1, z1 respectively 1 by 8, 0, 0, and x2, y2, z2 respectively 0, 1 by 4 root 2, 0. Now let's write down the equation in this form. So the equation of L1 is given by x minus x1 1 by 8 by x2 minus x1, that is 0 minus 1 by 8 is equal to y minus y1 that is 0 by y2 minus y1, 1 by 4 root 2 minus 0, and that is equal to z minus z1, z minus 0 by 0 minus 0. That is the 1. Now in the denominator you have the multiply throughout by plus 8. If you multiply throughout by plus 8 is the LCM of 8 and 4 root 2. So minus 8 if you multiply, this will become 1, and minus 8 multiplied by 1 by 4 root 2 will be minus root 2 and 0. So this is the equation of L1 in this form. Why are we writing in this form? And we know how to compute the formula for the shortest distance if I write in this form. So in the next slide we will again do the same thing for L2. So we now go to the next slide, and we have already seen L1 is the line x minus 1 by 8 by 1 is equal to y minus 0 by minus root 2 is equal to z minus 0 by 0. Let's call it as the equation 1. And L2 is given, that is a line in zx plane with x and z intercepts respectively minus 1 by 8 and minus 1 by 6 root 3. Therefore, the equation of L2 is given by x by x intercept is equal to x by x intercept plus z by z intercept is equal to 1, and it is zx plane, therefore y is equal to 0. So you will get x by x intercept minus 1 by 8 plus z by z intercept minus 1 by 6 root 3 is equal to 1. This is a zx plane, therefore it is y is equal to 0. Right, this is a minus 8x minus 6 root 3z is equal to 1, where y is equal to 0. Agreed. We take two convenient points on this. So we take minus 1 by 8, 0 comma 0 satisfies this equation, and 0 comma 0 comma 0 comma 0 comma minus 1 by 6 root 3 satisfies this equation. These are the two convenient points we have taken, like what we did in the case of L1. And we recall this result, that is the equation of the line passing through two given points A and B with coordinates x1, y1, z1 and x2, y2, z2. And the equation of such a line is this one. So like in the case of L1, we write down. So that is x minus 1 by 8, that is x plus 1 by 8 by x2 minus x1, that is 0 plus 1 by 8 is equal to y minus 0, y minus y1, 0 by 0 y2 minus y1, 0 minus 0, that is equal to z minus z1, that is 0 by z2 minus z1, that is minus 1 by 6 root 3 minus 0. And now what we do is you multiply throughout by 24 root 3, that is the LCM actually for 8 and 6 root 3, 24 root 3, then it will be 3 root 3 here, 24 root 3, there will be minus 4 here, this is 0. So x plus 1 by 8 by 3 root 3 is equal to y minus 0 by 0 is equal to z minus 0 by minus 4. Let's call this as equation 2, which is the equation of L2. Agreed. So we have L1, right? That's the equation 1. We have L2, that's the equation 2. So these are the two lines. X minus x1 by a1 is equal to y minus y1 by b1 is equal to z minus z1 by c1, and likewise this one. And we know what is the formula for the shortest distance between the lines. This is the first line passing through x1, y1, z1 with direction ratios a1, b1, c1. This is the second line passing through the point x2, y2, z2 with the direction ratios a2, b2, c2. So 1 and 2 are here. And what's the formula? Shortest distance, that is modulus, inside the modulus, determinant whose first row is x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, second row, third row a2, b2, c2. That is the determinant by under the square root of b1 c2 minus b2 c1 whole square plus c1 a2 minus c2 a1 whole square plus a1 b2 minus a2 b1 whole square. This is actually under the square root of sigma b1 c2 minus b2 c1 whole square. That's the thing. And we know everything. x1, y1, z1 is minus 1 by 8, 0, 0. x2, y2, z2 is 1 by 8, 0, 0. a1, b1, c1, 1 minus root 2, 0. a2, b2, c2, 3 root 3, 0 minus 4. So now D is the distance, shortest distance. That is the shortest distance is equal to modulus. Inside that, the 3 by 3 determinant, that is the x2 minus x1, 1 by 8 minus 1 by 8, that is 2 by 8, that is 1 by 4. And y2 minus y1, 0 minus 0, 0. z2 minus z1, 0 minus 0, 0. And a1, 1. b1 minus root 2, c1, 0. Right? And 3 root 3, 0 minus 4 here. Agreed. By under the square root of b1 c2, that is 4 root 2 minus 0 whole square. Agreed. Plus c1 a2, 0, 0 minus 4, that is 0 plus 4 whole square, plus a1 b2 minus a2 b1, a1 b2 minus a2 b1 is minus a1 b2 minus a2 b1 is actually plus 0 plus 3 root 6 whole square. Agreed. And this is a upper triangular determinant, and the value of the determinant is the sum of the product of the diagonal entries, that is 1 by 4 multiplied by minus root 2 multiplied by minus 4, that is root 2. When you simplify this one, you will get under the square root of 102. The under the square root of 102 is root 2 multiplied by root 51. Root 2 cancels, and we will get 1 by root 51. That is D. So 1 by D will be root 51. 1 by D square will be 51. That is D power minus 2 is 51. So that's what precisely wanted in the question. So the answer is 51. That is the detailed discussion of the solution of the problem based on the concept of shortest distance from the three-dimensional geometry. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.